Hello and welcome to Tiny Code Christmas Day 8, Round and Round. If you're watching this on Monday the 16th of December, there is a Byte Jam tonight at 8 PM UTC on the Field Effects Twitch. Hope to see you there. Today we're going to be talking about rotation, and then we're going to be combining it with a pixel effect to create this. This effect is really more than the sum of its parts. It is some rotating circles and a pixel effect that copies the pixel down the screen, and when you combine those two things you get this absolutely beautiful thing. So Aldroid did this in a Byte Jam last year, and I thought it was the perfect way to introduce rotation. Before we split off into our platform specific sections, just want to talk again about the sine and cosine and this unit circle that we have here. So we saw earlier that when we rotate this point, we're not actually rotating it, we're simply getting the sine and cosine of an angle, and that dictates what point on the unit circle our dot is going to be on. So you can see here the 1, 0 is the coordinates at this point, and that is the sine of the angle and the cosine of the angle. And again, the sine of the angle giving the y value and the cosine giving the x value. And you can see as it moves around there, it is giving those values between -1 and +1. These are values that we can then multiply to move that point out further from the radius. So for example, if we have this point here at 1, 0, if we multiply that by 10, that point now becomes 10, 0. And we can do this for any of the points that we get from our sine and cosine, and that will allow us to rotate those circles around like we saw in the effect. So this is the code that we're going to start off with for our rotation on tick 80. I've aliased cosine, mat.cos and mat.sine to cos and sine. I have my function tick. I'm clearing the screen. I'm setting t equal to t plus 0.05, and we might come back and modify that in a minute. And then we've a equal to t, so I'm setting the angle equal to t, and at the moment all I'm doing is drawing a circle. So the setup for what we want to do is to have this circle move out a bit from the center and rotate around it. So we saw how we can do that with the sine and cosine. So what I'm going to do is I'm going to add cosine of a, and I'm going to, on the x-axis, and I'm going to add the sine of a on the y-axis, or the y value. And if I run this now, you'll see that that is in fact very slowly rotating around the center point, and the values of cos and sine are going to be -1 to +1, so that's rotating around that at about 1 pixel. So what we need to do is bump this up a bit, and I'm going to maybe change it to 10 multiplied by cos a, and we'll take a look at that first, and we'll see that we have it. You can see it does move up a pixel and down a pixel, so there is definitely rotation happening on the y as well. So then I'll put in 10 here as well, and we now have a rotating circle. So I'll up these a bit, maybe make it 40. Now, very nice. So that's our code for just one of these rotations, and when we're working towards our target effect, there was 5 of them on the screen. So we need to take this one circle, make it 5, but they have to be evenly divided over the full entire length of a circle. So we want to split evenly in terms of the angle between those circles. So what I'm going to do first of all is I'm going to make the angle equal to mat.pi multiplied by 2. Now what that is, that basically says make the angle 360 degrees, because half a circle is mat.pi multiplied by 2, you get the full rotation, and then I'm just going to divide it by 5. So that angle is going to be mat.pi multiplied by 2.5. So you can see down here it is moved it from the circle down here, and we need to, obviously I can maybe add time to that, and we'll see that it does the exact same rotation. no problem, but this time that it's just in, it's not starting from angle 0, as it was the first time. It's starting from 1/5 of a revolution. So now that we have this, we want to figure out how to actually do R5, and that's simple enough. For I equal 1 to 5, and what we need to do here is we have our angle A that we were using to create that. I'm going to bring this down inside so that we calculate the angle each time, and all I'm going to do is I'm going to multiply it by I. So take that angle, so take a full revolution, divide it by 5, and then multiply it by 1, 2, 3, 4 or 5, and then I'm going to add t to it. And what that means is that the angle that we're going to be using will be different each time around the for loop, and it should give us this. And if we want to make that 8 circles instead, we just need to change both of them, and we get 8 nice evenly spaced circles. So you can see there that it is iterating 5 times. It is calculating 1/5 of a revolution, multiplying it by which circle we want, 1, 2, 3, 4 or 5, adding t to it so that the angle does change with the time. Then we are using the circle, 120 plus 40 multiplied by cosine of A, and then we're adding that to the sine of A. So A is the value that's changing, the angle, and then the circ function gets called obviously 5 times with the different angle, and it gives us this lovely rotation. So some things that we can do to make these rotations a bit different is, obviously, you saw it when we were setting it up, we can vary the x and y to make them give it a bit of a different spin, and we can also get the sine and cosine of different angles. So for example, if I get the sine of A and the sine of A divided by 2, it'll give me some kind of an effect like this, and if I maybe make this divided by 3, you'll see that we get this type of movement. And these are called Lissajous curves, and we'll be taking a bit more of an in-depth look at them tomorrow. So I'm just going to put this back, and the next thing that we have to do as part of the effect is the radius of the circle is changing. So I'm just going to add sine t to that, and we'll see that it is slightly changing there. Obviously sine t is plus or minus 1, so that's 3 plus or minus 1. So let's make that a little more prominent. Okay, maybe too prominent, but you get the idea. And if I change this to maybe 7 and this to 3, that will capture it all there. So you can mess around with these and see what exact kind of a setup you want, whether you want them to go from bigger, smaller, or to disappear or not. So you can play around with that radius of the circle here, and that should give you a pretty good idea. So I'm just going to reset this so that it is going around as per normal. The next part of the effect then, so this is a combination of 2 effects, so you're probably going to have to change the color as well as you're rotating. And then the next part of the effect is simply to copy the pixel on the right to the left. So I'm just going to set up a for loop, and what I want to do is just visit each pixel on the screen, and again I'm using the shorter one from yesterday. And inside here what we have to do is copy the pixels from here down along and adding 1 to their color or subtracting 1 from their color depending on the effect that you want. So that will take the frame at that point in time essentially frozen. So I'm just going to make t equal to t here. So I'm just going to make t equal to 1 here. So it will basically take this frame, it will move all of these pixels down 1. So you will see that these will have moved 1 pixel to the left. Then you move on to the next frame, having this been moved, and then you move on to the next one. So you will, for example, maybe get rid of the CLS function, and if we get rid of the CLS function, you'll start to get an idea of how this effect works, but we just have to take those pixels and move them down every frame. Another component to the effect that I'm not going to cover here is the palette. So you'll have seen that the example doesn't have the standard Sweetie 16 palette, and there's code that's on the website that allow you to change that palette, and we'll be taking a look at that in more depth later on, but you can just copy and paste that code for now. So the first challenge is to get the effect working. The second challenge is to do it in a maximum of 256 characters. The expert challenges are specifically related to rotation, not specifically this effect, so check out the website for those. Best of luck. So this is our starter code in Pico 8, and you can see here that it has exactly 1 circle and it is drawing it in the center of the screen. So to take a look at our setup, we're clearing the screen. We'll need to remove that later. We have t equal to time. I'm setting the angle of our rotation to A. We haven't done it yet, but we'll take a look at it in a second. So the angle changes with time, and I have my circ fill here. So first thing I'm going to do is add cosine of A to the X, and I'm going to add sine A to the Y, and I'm going to run it, and you'll see that that is in fact rotating around 1 pixel. So what we need to do here then is maybe multiply that out by 5. I'm going to split this over 2 lines because it's getting a bit unwieldy. 5 multiplied by, and you'll see that we do get that rotation. Now I'm going to maybe make this 30. Perfect. So that gives us our cosine, our sine. We multiply it by 30, that gives us our rotation, and the next thing we need to do is we need to actually make 5 of them. So in this case, since we have the ability in Pico 8 to use turns instead of angles, this makes this slightly easier. So I'm just going to set up a for loop for I equal 1 to 5 because we want 5 circles, and it's very easy to modify the number of circles then. Just change our for loop and our angle, and I'm going to make A equal to 1 divided by 5, because again 1 is 1 full revolution or 1 full turn in Pico 8, and then I'm going to multiply that by I. So we take 1/5 of rotation and we multiply it by 1, 1/5 multiplied by 2, 1/5 multiplied by 3, 1/5 multiplied by 4, and we get this. The 5 circles laid out nicely at perfectly even intervals, and then if I want to animate them, I just add t, and t is a little bit fast there, so I'll just divide that by 2. Or 3. Perfect. So that makes our job a lot easier in terms of not having to think about radians, and we just 1 divided by 5 gives us 1/5 of a rotation. Multiply that by 1 to 5, add t, and we're good to go. Other part of it is that the sine of the radius, we're given a modification to make it grow and shrink, and again we can do that with, for example, let's say 5 plus sine t. So you can see that does it there, but it's very small, so I'm going to maybe make this 4 plus sine multiplied by 2. Yeah, so that goes up and down. So the next thing that we need to do is a for loop to visit every pixel on the screen. So maybe for y equal 0 to 127, and then for x equal 0 to 127. Oops. And what we'll need to do here is copy every pixel down along from the right hand side one at a time. So we're going to have to visit every Y pixel and move it back one. So I'm removing clear screen now, and you can see that it gives me this, and I'm just going to change the color to for a second, and you'll see that it is now changing the color. There's no CLS. I can put in a clear screen up here before the function call so that we're not looking at our terminal, and you see that the pixels don't get erased now and they're drawn on top of each other. So if you take, for example, that pixel, if I put back in CLS for a second, if you take these pixels, move them down one, and then you're drawing the next frame and the next frame, the colors will appear to be dragged along the screen as they were in the example at the start. So today's challenge is to get the effect working, and the second challenge is to get it done in 256 characters. And then there's an expert challenge on rotation that's not specifically related to this effect that is up on the website, so feel free to give that a look as well. Best of luck. Don't forget to come back tomorrow for the next challenge.